Alright, so now we've got all the basics sorted out. How how everything has charges, how we can charge bodies. So now we're gonna get into the real stuff. Let's move into the real stuff. So let's talk about the properties of charges. Now when I say the properties of charges, no big deal. I'm just telling you what I see a charge, what comes to my mind, what that charge does, and what it's capable of doing. The properties of charges. So let's talk about that. The props, right? The properties of the charge. So the first property, everybody knows this. The first property is we have two types of charges, positive and negative, right? Two types of charges, positive and negative. That's a property. First property, positive and negative. The second property, alright, this is also really simple, everybody knows this. The second property is, can anybody guess? It's that like charges repel, right? Like charges repel, unlike attract. I mean, we already knew this, that like charges repel, unlike charges attract. That's the second law. The second property. Now, the third property is, well, this is, if you haven't ever studied electrostatics, this is the only first time thing you're going to see. What does this mean? Right? So let's take a look. The third property says, okay, that charges are always quantized. Quantized. Charges are always quantized. Now, what does this mean? A big word. Charges are quantized. Let's see. Let's analyze the word. Quantized has something to do with quantity, maybe? Yep, could be. Quantity. It means that if I have a charge, alright, what causes charges? What causes a body to be charged? We looked at that. It's the movement of what? Movement of electrons. Now, an electron is negatively charged. We knew that. But what is exactly the charge of an electron? Now, I told you here's where we're gonna get into some real stuff. So, well, first of all, the person who figured out most of this stuff was Coulomb, right? So, the unit of charge, just as the unit of length is meter, the unit of time is seconds, the unit of weight is kilograms. Same way, the unit of charge is Coulomb. I guess that's the right spelling, and it's symbolized by C. Okay, so the charge of an electron, and you should probably remember this, not that hard a number, is 1.6 times 10 to the negative 19 coulombs. That is the charge of an electron, which means that one single electron is actually, it barely has any charge at all. It's 1.6 divided by 10 with 19 zeros. That's what this number represents. And Q is how we should normally represent a charge, but since we know this body, we're just going to write E there. E, which is charge of electron, is 1.6 times 10 to the negative 19 coulomb. Now, why am I telling you all this? Why do we have to remember 1.6 into 10 raised to 19? Because we knew that a body, when it charges another body, or if any body is charged, right, electrons are things that cause it, which means if I am neutral, something else is negative, one electron jumps, how much charge moved? That much charge moved, 1.6 into 10 raised to 19, which means you can't have half an electron moving in, you can't have 1.5, you can't have 2.5. Quantized just means that the electrons move as one whole electron. If I want to go to the neighbors, I have to move together. I can't give them my head. Basically that. The electron, if it leaves, it takes everything with it. It takes the whole body and goes. So it means that if I want to charge a body, it will be charged 1.6 in 10 raised to minus 19 coulombs times how many electrons move. So if 2 electrons were to move, it would be 2 times that. If 3 electrons were to move, it would be 3 times that. If 103 electrons were to move, it would be 103 times that. Basically, it means that charges are always quantized, which means that they always will be an integral multiple of that. Ooh, integral multiple. It just means integers are whole numbers like 1, 2, 3, 4. 0.5, not an integer. 0.6, not an integer. 1 by 3, not an integer. So it just means that you have to have whole numbers of that. So an integral multiple means a multiple of a whole number can only be the charge on a body. So if I want to say what the charge is, now you might say, yo, but this is like 1.6 times 10 to minus 19. That's like, but that isn't the electrons moving. That's just the charge of a single electron. Don't confuse it with the charge when you charge a body. It just means that it will move at this rate. That is the third property, which is the only new property, which says charges are quantized. That means that they have to move with this value, because this is the charge of an electron. Now, the last property is very simple. The fourth property is just that everything has to be conserved, which means that if an electron were to jump there, the electron still exists, which means that in all of this mess, electrons moving all around, if there were 10 electrons, there must be 10 electrons in the end somewhere. They have to end up somewhere. You can't lose any charge anywhere. If I was in friction, when we shook it, electrons moved from here to there. They still moved there. The total charge was the same. When I say the total charge, I mean if I had one positive charge here and 2 negative charges, the total charge, let's just say the total was 3. 1 particle, 2 particles. Now remember, I don't remember what I said. 2, okay, whatever. 1 negative, 2 positive. Alright? So when I move it, because we have 2 positive here, what's going to happen? This is positive, this is negative. The electron will tend to go in here. In the end, this will have nothing. This will have 3 particles. But the total is what? The total is still 3. That's just the last property, that everything will be conserved. So now we know the properties